What is visible now? What can you see?
It's you are presenting, but not yet displayed any presentation, sir. It's showing
Okay.
little blur.
Okay.
Yes.
To screen. The screen. What about now?
It's almost same, sir. So
Same. Okay.
yes, sir.
Goes on.
So, have you shared the screen, sir?
Yeah. Actually, I'm joining from Mac.
Okay.
Okay, not from Windows laptop. Okay.
Okay.
So, because here it is browser is different, right? So
Yes.
option. Go to share window. Window. Let me check once, otherwise I will use my Windows laptop. That's
Yes,
very
sir. Sure.
Good afternoon, sir.
Good afternoon. Yes.
Yeah. Thank you.
Share the screen.
Sir, can you open presentation there or something?
Where is it?
Actually, whatever you shared, we could see, I think, blurly that members presented there, actually. I think it's sharing entire screen.
Yeah, let me check whether, once again.
Yeah, if you open, now we can see your email something. Yeah, we can see your presentation.
Yeah. But what about my video?
It's there, sir. Means
then it is fine. It's okay.
Yeah, fine.
Okay. I have to swipe the screen. Okay. Now you are able to see, right?
Yes, sir. Yes.
Okay.
So can you go to next slide, sir? So is it slide changing effectively take? Yeah, it's fine. Yes.
Correct?
I hope you're right.
Oh, fine. Okay. So now time is 2:47 in my clock.
Yes, sir.
So I will turn off my video. So I will turn on 2:55. Then we will start.
Yes, sir.
Okay. Let it be connected. Okay. Fine.
Yes.
Okay. And what about the students? I heard that it will be live telecast something.
Yes, sir. So we are projecting in classrooms. So we have like engineering first year 2 classes, second year 2 classes, third year 1 class, and final year 1 class, sir.
Okay. So you are presenting in their classrooms.
Yes, sir. Yes. So some will be joining in this
from
Google
their
Meet
devices.
Yes. So some will be joining in Google Meet, and some will be watching over the YouTube, sir.
Okay. So now time is 2:48. So I'm here. So you just give me a signal. I will start.
Sure, sir. Sure.
Okay.
Thank you.
Fine.
Yeah, Ratnakar sir.
Yes, sir. Yes.
So shall we start the session?
The
Students
4
are,
minutes. 4 minutes
yeah,
only, sir.
yeah.
Yes.
Yes, sir. Yes, sir.
Shall I start?
Sir. We wait 1 minute, sir.
Okay, fine.
Yes.
So I request our webinar chair, Ratnakar sir, to introduce the today's speaker, and then we'll start the session.
Okay, sir. So shall we start now, sir? Sir, actually it's 2:57.
No problem, it's okay. We can go ahead. Okay.
Jyotilal, sir.
I don't have any problem.
Yes, sir. Students have been joined already.
Okay.
So we can start.
Yes. Okay. Right. So good afternoon, respected professor, my dear colleagues, student friends. Welcome to 9th webinar conducted by Department of Electrical Engineering on smart grids. It's my pleasure to introduce today's speaker, Professor S. Shivasubramani. Let me say a few important milestones of Professor career. So Professor obtained his BE in Electrical and Electronics Engineering from Madurai Kamaraj University, and he obtained his Masters in Power Systems from Anna University and has done his PhD from IIT Madras. Since May 2013, Professor has been associated with Indian Institute of Technology Patna. Presently, Professor is working as Associate Professor in the Department of Electrical Engineering at IIT Patna. So Professor is an expert in the field of power system optimization and smart grids. So I am sure we will all benefit from his expertise in this webinar. So without further delay, I welcome Professor S. Shivasubramani, and the floor is yours, sir.
Thank you. Can you hear me?
Yes, sir. Yes.
Okay, fine. Okay. I think my screen is also visible.
Yes, sir. Perfect.
Okay, fine. Thank you for the nice introduction. Okay, first of all, I would like to, thank you for giving me this opportunity to share my expertise with your students. So, as he said, the title of the talk is Smart Grids. It can be called two-way flows of electricity. So the talk will be mostly an introductory nature. I know that I heard students from first year to final year are there. So I know first year students may not be aware of what a power system is. So I will talk about in general so that all can understand. Even students of final year and third year will get much more insight. So first year and second year students will get something about what it is, why everybody talks about this one. So it will be of mostly an introductory nature. If you look at the overview of my talk, first I will discuss what an electrical grid is and why we need to make it smart. I will talk about what smart grid is, why we need to make it smart. And the two major components of smart grids. One, electric vehicles. Now everybody is talking about EVs. I will discuss a few things in the upcoming slides. And finally, I will talk about the other component of smart grid is microgrid. So I will touch upon all those things. Finally, at the end of today's talk, you will come to know what a smart grid is, why we need to move towards that one, what are the main components of that one. You will come to know about it. So before we dive into the actual topics, so let me introduce what an electrical grid is. Right? Okay. Many of you are familiar with this term, maybe except first year and second year students. So we all know that whenever we flip a switch in your offices or classrooms or homes, we get electricity, but electricity mainly it's used. Electricity nowhere it is used in its raw form. We mainly use electricity for some other things. Whenever we feel hot in our rooms or offices, we flip a switch or an air conditioner, so that will cool or that will do the purpose whatever we want. So that electricity has to come from all the way from generating stations, which are mostly located far away from the places where we live. So for that, you need a network to bring that power from the sources to the load points. So that grid, that is a term we give electrical grid, which is an interconnected network of transmission lines, substations, transformers. The purpose of that interconnected network is to take power from generating stations to load centers. That is the main purpose, but that is an interconnected network. So why we need to go for interconnection? The main reason for going for interconnection is to improve reliability and economy. So this concept, that interconnected network concept, was conceived almost, or you can say more than 100 years ago. When the electricity was invented, first they started with an isolated system, a source supplying load through cables. And they found that that system was not reliable and economical. So that is why they went for interconnecting various sources to form a network, so that if anything goes wrong with one system, still the customers or load centers can be supplied through other sources. That's why the interconnected concept came into picture, and that concept was conceived almost 100 years ago. We have been using the same thing till today. But even though there are advantages, there are some disadvantages. The disadvantages, you can see if there is anything happening in one particular part of the whole system, it will affect the other things as well. So we should make the system so that it can withstand those things. But that is very rare, but if it happens, it will be severe. So that's why we have seen some blackouts, across the world. So in some situations, it may be severe, some situation it will be less severe. We have also one blackout in 2012 in India. That time, the entire North Indian grid got collapsed. There was no power for the entire North India, for almost 2 to 3 days, except in some small pockets. Whereas the southern part of India, that time it was not connected to the northern part, the remaining part of India. So it was not affected. But after in 2014, the even southern part of India was also connected to the remaining part of India. Now India is one grid, only one grid. So that means it's an interconnected system. So the system is so vast. So it has to be, because there are a lot of advantages, as I mentioned here. The disadvantages, they mentioned in this thing. If there is any problem, but it is very rare, okay, fine. But that was the concept which was conceived 100 years ago. We have been using it. So what is the problem? Why should we make it smart? So I'm going to give the term traditional grid. That means we have been using it traditionally since electricity was invented. So this is how the traditional grid looks like. There will be bulk power plants located far away from the load centers, because they have been located far away from load centers mainly because of availability of resources. Because they have what's happening in the power plant is mainly conversion of energy from one form to the electrical form. So the form which is available may be coal or water or nuclear availability or other factors. So they all drive the location of power plants. So big power plants are located far away from the load centers. They feed power to the grid, transmission grid. So that is an interconnected network. And then that grid takes power from or energy from the power plant to the load centers. So this is how the traditional grid is there. So suppose you get power from nearby substation, you do not know where that energy is coming from. You cannot say that it is coming from a particular power plant because everything is interconnected. So that is the concept. So that's why I'm calling that existing system as the traditional grid. So everything is interconnected. You can see a power system, it's a combination of generation, transmission, and distribution. Everything is interconnected. Okay, we have been using it. Right. Now, before I talk about why we need to make it smart, I will throw some figures on the current power generation and capacity of from Indian perspective. I will talk about that one so that you will get some ideas. And then why we will come to know why we need to make it smart and what are the drawbacks in the existing system. Okay. If you look at the installed capacity in Indian context, if you look at this is on us on June 30th June 2023, just 2 months ago. The total installed capacity is sum of all three things. If you look at the share of thermal, which is around 238 gigawatt. Thermal means which includes coal, oil, gas. These three things constitute thermal. So their installed capacity is 238 gigawatts. When it comes to renewable energy sources, it's 30 gigawatt. So which is 31% of the total installed capacity in India. Nuclear, only 7 gigawatt. It is only 2%. Because it's very difficult to expand because of a lot of public opposition is there for that part. If government wants to construct a nuclear power plant, they have to, convince locals. Many issues are there. That's why they're not able to go ahead. Hydro, because of availability of water resources, you cannot have hydro plants at various places. You need water resources. And also expanding that is also not, so easy, even though it is clean. But if you look at the share, it is only 11%. But what we are what we have been doing for the last 15 years or 20 years, you can say, if you look at the renewable energy sources, the share 31%. 15 years ago, it was only 2 to 3%. Now we have come to 31%. I'm sure within 5, 6 years or 10 years, it will become 50% also. It will become 50 because that is the commitment we have to do. We have to increase our renewable energy sources share in the energy production by some percentage by some year. That is the commitment we gave to certain, in the climate accord meet. So we have to do. So that is why you can see. So that shows that we are going to, integrate a lot of renewables into the grid. We are going to integrate. We have to integrate. And we know why we need to integrate because there are a lot of environmental concerns. So in order to alleviate environmental concerns because of greenhouse gas emissions, so we need to minimize, those things. For that, we have to increase the share of renewable energy sources. Even though the installed capacity, we have 31% renewable energy, 58% thermal, 12% everything. Because even though we have some installed capacity, it doesn't mean that they always, give electricity. Sometimes the plants are, not functional. Sometimes they don't operate at their full capacity. So there are a lot of other issues. So if you look at the electricity generation, that is the installed capacity in terms of megawatt or gigawatt. This is in terms of units, electricity generation. If you look at in a particular month in this year, let us say in May 2023, the electricity generation was 145.63 billion units. India generated that much amount of units. And you all know, India is the third largest producer of electricity and consumer also. Third largest after the US and China. The US and China. But if you look at the electricity, whatever electricity we consume now, 76% of electricity is still coming from thermal. That means even though we have sufficient installed capacity in renewable energy sources, in hydro and other things, in clean form, but still we are getting energy from, you can say that energy which you are getting is not from clean form. That means we have to burn a lot of coal, then only we can get this energy. So 76%. So we have to reduce this also. This is due to, because renewable energy, we have sufficient installed capacity. Sometimes, you know that if there is a cloud cover, solar will not produce any electricity. If there is no wind turbines will not produce any electricity. So because of various reasons, we can get only 13%, right? So if we increase that one, we will increase this also. So the bottom line of this slide is, still whatever energy we get, even though we talk about renewable energy sources, the electricity which we are getting today also, mostly it is from thermal. So that has to be reduced. Right, now when it comes to greenhouse gas emissions, not only electricity sector, contributes to this one, but other sectors as well. So electricity accounts for only 25% of greenhouse gas emissions, whereas manufacturing sectors, industries account for 31%. Even buildings, they produce greenhouse gas emissions, they account for 6%. Transportation accounts for 14%. And agriculture, even for farming, agriculture even accounts for 24% of greenhouse gas, mainly methane and other things. But now, before pre-industrial era, that means 100 years ago, agriculture was there, manufacturing, transportations, and electricity production also was not there. So whatever we generated greenhouse gas emissions that were consumed by carbon sink. So that's why that global warming problem did not arise. But after the industrial era, because of a more amount of greenhouse gas emissions, is pumped into the atmosphere. So the carbon sink is not sufficient to capture them. So we have to limit that emissions. So now if you look at this particular slide, if you take electricity and transportation, forget about manufacturing and buildings, that they are not in our purview because we are all electrical engineers. So we have to see how to reduce emissions from the electricity sector. And transportation nowadays, the whole transportation is being electrified, that you all heard about, every day you hear about that one. So if you take only these two sectors, electricity and transportation, we can reduce emissions by electrifying as well as by integrating renewables into the electricity production. That means we are going to integrate not only renewable energy sources for producing electricity, but also we are going to convert the current transportation sector into green form by pumping in more amount of EVs into the system. So these are the things we have to do. So when you do this one, there will be some problems in the existing grid. That is the reason why we need to make the existing grid smart in order to accommodate those things. So before we see, if you look at country-wise, which country is emitting more emissions? If you look at country-wise, China is emitting the most amount of emissions, you can see, 30%. If you look at India, it's only emitting 7%. Because that is, we are the third largest producer. Mainly from this, you can see emissions combinations altogether. China is contributing more. The next US, and then European Union and other countries. So you may think that they have been doing, they should also do. Of course, they are also taking some steps to reduce their emissions. There is commitment of every country to reduce their emissions so that the temperature rise can be contained within 1 degree or 1.5 degrees Celsius. That is the idea. Otherwise, we may not be able to save this planet for future generations. That is why all countries have committed to doing something in their respective sectors. Okay. Now, after having thrown some light on installed capacity, electricity generation, and emissions, or how much we are doing, so these are our goals that we have to achieve these goals. What we have committed is every country has to contribute something to reduce the global temperatures. Is there any problem? Shall I go ahead? Hello? Hello?
No, sir, please continue. By mistake, I think I muted the one of student.
Okay, fine, no problem, sir. Okay,
please continue, sir.
Okay. So we have to reduce the global temperature below 2 degrees. That's what I talked about, pre-industrial levels. For that, every country has to do something. What we have committed is India has committed to increasing its renewable share to 40% by 2030. By now we are in 2023, so we only 7 years are left, but we have we have reached 31%. So it's not a big deal in reaching 40%. Even we will go beyond that also. That means 50% also we may reach by 2030. And also we are trying to, make the transportation. That means we are trying to bring in 30% of total transportation by EVs by 2030. So these are the goals we have to do. So that there are other things as well, but these are the things from the electricity perspective. We have to pump in more renewables as well as bring more EVs. 30% of transportation should be from electric vehicles by 2030. Okay. So if it's that things are clear, so we are going to bring more renewables, more EVs. So finally, EVs have to get charged from the electrical grid. So the traditional system which we have been using since electricity was invented has some difficulties in accommodating those things. So that is the reason why we need to modernize. The existing grid or traditional grid should be modernized, because apart from these things, if you bring more EVs, the demand will also increase. And apart from EVs, since our country is developing, so electricity consumption will also increase. So there is a rapid growth in power demand. So in order to meet the rapid growth in power demand and take care of environmental concerns, the existing grid needs to be modernized. There is no other way. And we are all aware of high losses, particularly in Indian perspective. 25% of the electrical energy is lost in transmitting from source to the loads. That is the conventional system. That is how the conventional grid works. Electrical power is generated at large, far away from load centers, and they are transmitted. It is transmitted over long distances to load centers. So in doing that, we end up in high losses and low efficiency. So that you can see 25% is lost in that process. So why should not we generate near the load center and consume it there itself instead of generating far away and transmitting over long distances? So why should not be changed? That is why these are the things which force us to look for modernization. And also environmental pollution, because still most of the energy is from thermal. So that emits a lot of greenhouse gases into the atmosphere. That has to be cut down. And then if you look at the cost of electricity, in most of the parts of India, it's almost 6 or 7 rupees per unit. If you buy from, if you produce on your own using solar or something, it can be even 2 rupees or 3 rupees also. So the cost of electricity there, it's high. So we have to look for ways by which it can be minimized. And apart from that, quality. You need to get quality supply. That is missing in many places in India. Even in many places, even though we get uninterrupted power supply, the supply may not be quality. That means the voltage and frequency will not be, may not be within that required level. And even if you get, sometimes the power is not reliable. And if the existing grid, if there is any fault, the entire grid may collapse. So there are some issues with that, the existing system. And we need to modernize, as we discussed in the previous slide. We are going to bring 40% or 50% of renewables into the system. So the existing grid has to accommodate them without any problem. And if you look at the infrastructure of the existing grid, this was built 50, 60 years ago, and we are using the same thing now. Of course, it must have aged. That means it shows that all the equipment in the existing system is working close to its limit. And it is also getting aged. So we need to, redo something. And then they are operating close to its limits. So these are the reasons which force us to look for modernization. These are the requirements. Because of them, we are going for modernization. Now, how this concept of smart grid came into picture. In the conventional system, we are using electromechanical meters. at home, if you look at this one, we normal in the olden days, we use meters. Later on, those meters have been replaced with some digital meters. And then later on, some parts, they have been replaced with meters which can have some communication facility, so that utilities can contact consumers. Consumers can interact with utilities. So two-way automated metering infrastructure. And then if you have meters across all the system, across the entire system, so that each and every component of the system can interact with others, so that you can form the system somewhat, in an interactive manner. This will help us improve certain things. So everything, we were using electromechanical meters, and we changed with one-way automated reading. That means only utilities or electricity boards can interact with the meter through one-way communication. Then it has been replaced with two-way meters, so both parties can communicate. And then this is how this will evolve. And then if you have systems everywhere, many places, if you have those kinds of components, so all can interact. So that will help us do something. Okay, that means we have to invest something. It is not smart grid. What I'm going to talk about now, from the next slide onwards, it doesn't come free of cost. That requires some investment. You have to do something, because you have to invest. Then only you can make the system, reliable, efficient, economical, everything. So you have to do some return, invest, and you should look for. Then only you can expect some functionalities. So the concept of smart grid was born maybe 10-15 years ago, particularly in the US. And the National Institute of Standards and Technology in the US was asked to define what a smart grid should be, because we need to modernize it. So when you modernize it, why can't we make it smart, so that we can improve the existing conditions, whatever the traditional grid has. So they came up with some conceptual model. They were asked to do something. The conceptual model, they said that it should be able to support two-way flows of electricity. Whereas if you look at the traditional grid, which I showed you in the very beginning, the power is unidirectional. Electrical flow is unidirectional. The power in the conventional system has to flow from generation to the load center, one way. But now, if you want to improve the existing system, because we have to accommodate the existing system, accommodate more renewables and take care of all other requirements, for that the one-way flow may not be sufficient. The power flow should be bidirectional. So the modernized grid, that should enable bidirectional flow of energy, and it should use two-way communication. Then only you can make the bidirectional power flow. So that means every component has to communicate with other components. So it should have bidirectional flow of electricity and two-way communication, right? So that will lead to an array of many functionalities and applications. So they came up with a conceptual model, and they said if grid should be smart, then it should have all the functionalities given in this particular slide. That means customers in the traditional grid, they can only consume, but the smart grid, even they can also generate electricity. They can generate electricity, they can consume themselves. If they have some surplus power, they can feed the power back to the grid. So they will also be, producing electricity. So they will not be they will not be called consumers. Since they produce electricity, they can also be called prosumers. They call prosumers. They produce and consume. So every component, transmission company, they can also, generate, consume, and not consume. They can communicate with others. They can involve in these transactions. So every part, you can look at these lines. These lines are communication lines. Everybody has to interact with others. And electrical flows, there is no direction. There is no direction. There is no arrow mark you can see. That means it can go from any way. So there will be some utilities and it's a market system. People will participate in this thing. It's a conceptual model. This is how it will be. Moreover, smart grid is a vision. We have to work towards this one. You have to achieve step by step. Then only we can reach. It's not, an immediate thing. It has to be achieved in the long run. So finally, the conceptual model given in the slide should have in the system, then only that grid can be called smart grid. So even though there is no clear definition for the smart grid, sometimes people say it's a modernized grid, it's an intelligent grid, it's an IntelliGrid, it's an advanced grid, right? Which uses two-way flows of electricity, which uses communication technologies in order to improve reliability, efficiency, everything. People talk about, give many definitions, but there is no clear definition for that. Even though it doesn't have any clear definition, but it must have certain benefits. So a smart grid must provide some benefits. The benefits are obvious because we are moving from the existing grid to a new system. So that new system must provide certain benefits. Then only we will do. Then only we can invest something. So that if you look at the benefits in the smart grid, we should have improved power reliability, quality, and secure power because we are going to communicate with others. So that it should be also secure. The whole system should be secure. So that benefit should be there. It should provide. And the smart grid must utilize the facilities in an optimal way so that we can avoid constructing some underutilized power plants. So where this issue is there in the existing system. There are some power plants which are used only for certain periods of a day or certain days in a year. Remaining times they are idle. That means we have already invested a lot of money for that. But if you look at the utilization perspective, from that perspective, it is totally underutilized. So that can be avoided in the smart grids so that we can save some money. And then improving resilience to disruptions. If you look at the traditional system, suppose there is a fault, there is a problem in the distribution transformer located in your streets, you will all not get electricity till that part is repaired. That is how it works. Whereas in the smart grid, it should be fast. Suppose there is a problem in one of the distribution system transformer, that particular area should be able to get supplied through a different way. That means it has to adopt a different route. That means it should be fast and resilient. That benefit must provide. Then only we can call that grid smart. And also it should enable predictive maintenance. It should be able to predict maintenance of particular equipment and then take care of responses, problems automatically, self-healing responses to disturbance. It should be able to provide. The important thing is it must be able to accommodate more of distributed power sources, mainly renewable energy sources, batteries, right? Other things it must be able to accommodate. And also it should be able to accommodate electric vehicles, which we are going to see in near future. And those electric vehicles, sometimes they act as sources, sometimes they act as loads as well. Because this is how it works. And finally, consumers like us, we should have more choices. Those things are missing in the existing system. We don't have any choice now. Whatever government gives, we have to pay. If they fix it 7 or 8 rupees, we have to pay. And also, even if after paying, we don't get quality supply. Sometimes we don't get quality supply, sometimes we don't get reliable supply. So those things should not be there in the new system. We should have more choices. So a smart grid must provide the benefits given in the slide, even though there is no clear definition, but it must have all the benefits given in this. If you simply compare the traditional and smart, even though you are now clear why we need to make it smart and what are the benefits it must have, but we can compare them, right? Just for more clarity. In the conventional system, the communication is one way. That means from top down to bottom up, top to down approach. Top down approach, people say. Whereas in the smart grid, it has to be two-way. Electricity, two-way. That is the reason why I kept the title of the talk, Smart Grids, Two-Way Flows of Electricity. The electricity will flow bidirectionally. Customers will also send power back to the grid, and customers can also take power from the grid, sell power to the grid. Generation in the conventional system, it's centralized. They are located, power plants are located centrally in certain areas. Whereas in the smart grid, they can be distributed. Even there can be a small power plant near your load center also. Generation types, if you look at the traditional system, mostly it's conventional, whereas in smart grid, it is expected to have renewables. That means from sources which produce zero or low emission. When you talk about the T&D losses, I showed you in one of the slides, it was around 25%. That's quite significant, but that should be reduced. In some countries, even now also, in the traditional system, it is 7 or 8%, whereas in India, it is 25%. Even that has to be also reduced. If you generate locally and consume locally, it can be minimized to 1% or 2% also. Efficiency, the existing system low, here it has to be high. Customer choices, in the conventional grid, in some places there are some choices, but whereas in smart grid, the choices should be plenty. And then monitoring and control, if you look at the traditional as well as smart grid, here everything should be automatic, self-monitoring, self-healing, right? So these are the differences between the traditional grid and smart grid. Now, after having given the introduction of a smart grid and its benefits, now I will talk about two major components of smart grid, as I mentioned in the overview of my talk. The two major components. First, I will talk about the first component, which we are all familiar with this component. EVs in short form. Nowadays, the abbreviated term is familiar with everybody. EV, electric vehicle. Everybody knows. You can see a lot of EVs on roads nowadays. This is one of the main components in smart grid, because why there is a link between transportation vehicle as well as electrical system, because they are going to get connected to the electrical grid for charging their batteries, right? That is why we need to be concerned about this one. So we can define an EV. So an EV can be defined the way I have given in this slide, that an EV is a vehicle that uses one or more electric motors for propulsion. And there are various categories of EVs, and that I will talk about in future slides. The second component which I am going to discuss in this talk is microgrid. So I talked about what a smart grid is. So this term may, you may find it somewhat confusing if you are not familiar with this one, but I will finally discuss in detail so that you'll understand why this is also part of this one. Okay, so let us not talk about the definition now, we will talk about later. First, these are the components I'm going to discuss. EVs and microgrid. Micro, we are all familiar. Micro is a small term. Micro, 10 to the power, -6 we use macro. So normally we use that micro. So that means it's a small thing. That's what you take it for granted now. I will explain later in detail. First, let us talk about EVs. This is the first component I want to discuss here. So we know that all EVs use different energy sources for transportation. You can classify them based on the energy sources. If they use only batteries, you can say battery storage, EV, battery electric vehicles. Some EVs use solar panels, produce electricity, and that will be stored in battery and then be used to drive motors. So some EVs have electrical generators, some have fuel cells for producing electricity. Some EVs can be hybrid. They can have both internal combustion engines and electric vehicles for propulsion. So based on that, we can categorize them: battery electric vehicles, hybrid electric vehicles. If their input is from fuel cell or electrical generator or solar panel, we can classify them. But mostly they have batteries. The batteries get energy and then they store energy in the batteries, and then that stored energy is used for driving motors. Okay, so benefits, everybody's, everybody knows this one. No need to talk about this. It's very cheap, and that must also, you must also heard. Now the 1 liter of petrol is in India, it's almost 110 rupees. So 110 rupees, if you look at the kilometer it gives a two-wheeler. If you talk about two-wheeler, it will be around 40-50 kilometers. Whereas an EV for a full charge, because we charge from home, even if we charge from a public charging station, even if you do it in a fast charging station, it will not be so expensive. So one full charge may give 40, 60, 50 kilometers. Then if you look at the comparatively, if you compare, it's very cheap. 1 kilometer, if you look at in petrol, it may be 10 or 12 rupees. Here it will be very less, maybe 1 or 2, depending on the electricity price where you live. Very cheap. Maintenance, of course, very low. Only thing is the battery problem. Because nowadays, batteries are with longer life for coming up, and mostly environment friendly. That is the main reason everybody is switching to EVs. And it's very smooth. It doesn't make any noise. If you've driven, or if you've driven any EV, you will come to know that. And then a lot of other health benefits, because there is no vibration and other thing. And of course, it's from health perspective also it's good. So these are the benefits of EVs. Right. But now we have to talk about our problem. That means when they're connected to the grid, what kind of issues they are going to bring. So finally, they're going to get connected to the socket, maybe at home or in a charging station. So when they connect it to this one, if one EV is connected to this one, it may not be an issue. Assume that a lot of EVs, are connected to the grid simultaneously. If they all start charging simultaneously, that is going to be a big problem for the electrical system. That is why we need to make it smart. The existing grid may not be able to, accommodate all EVs. So, since it is going to get connected to the grid for charging, we can call that EV as plug-in electric vehicles. So they are called as, abbreviated as PEVs. So battery is rechargeable battery. They store, whenever the battery is depleted, they charge it and they store the energy in batteries and use it for propulsion. Okay. And then since they are connected to the grid, actually they are called plugged in. They're going to be plugged into the grid. And if you look at the types of PEVs, one is purely battery electric. Well, there is only one component, battery, that's it. The battery gets charged whenever it is depleted. And then there is one more type, it's called plug-in hybrid vehicles, electric vehicles, which will have an internal combustion engine as well, just to increase the driving range anxiety. Because the EVs, the main problem is charging and driving range anxiety, because people are worried about driving range. If even for a full charge, two-wheelers will give 56 kilometers, but cars, batteries, but they're very expensive and may give maximum 200, 300 kilometers. But after that, it has to be charged. So if you do it at a home, it may take 6 or 7 hours. Or if you do it in a charging station, public charging station, you can do it quickly. Even then it takes half an hour or 1 hour sometimes. But you have to find out where charging stations are there. So they are not available like petrol pumps. So these are the issues. They are the user issues, mainly users are concerned. That is range problem. One is range problem. The other problem is this charging problem, where it should be charged. Okay, if you can take care of them, they are different things. So that's why in order to increase the range, take care of the range issue, the people prefer to use plug-in hybrid electric vehicles instead of pure battery vehicles. So that if there is no electricity in the battery, there is no charge in the battery, then people can switch to internal combustion engine, we can move ahead. So that's it. Okay. But now, we should be concerned as electrical engineers, we should be concerned about the interaction between grid and EVs. We should be concerned because they are going to bring some, challenges to the existing grid. So when they get connected to the grid for charging, that is called grid to vehicle transaction. So the energy is flowing from grid to the batteries. That is to vehicles. That is called G2V, people say. They not only consume, but they can also give power back to the grid. That's what I said. EVs not only act as loads, but also sources. You can call them as portable batteries. Because wherever they go, they carry batteries. Suppose the batteries have surplus amount of energy compared to your use, you can give that power surplus amount of energy, you can feed it back to the grid. If for that you need a bidirectional converter, not all EVs have, but some EVs will have that in future also. So when they interact in this manner, when the energy flows from batteries to the main grid, that means they have to discharge. So that concept, that interaction is called vehicle to grid concept. So V2G. So you can see in this slide, the energy flow, it has been given in bidirectional arrows. So it can flow from grid to vehicle or vehicle to grid. So these interactions, for example, as I said, if all the EVs start charging, simultaneously, that is going to be a huge problem for the existing, for the power system grid. Suppose they help us in taking care of certain things by agreeing to transfer the surplus amount of energy from the batteries to grid. So, of course, with some incentives, when they supply, they should get some money for that one because they are going to act as a producer. So they should get this one. This will help us in meeting out certain objectives, taking care of some problems. So these are the interactions if you look at the electric vehicles. But when it comes to the transfer of energy from EVs to the main grid, there are some benefits. So these batteries will act as sources. So we can call them distributed energy sources because they are going to give some power. One EV, if you take power from one EV, that may be very minimal. But assume that you are taking power from a lot of EVs. That will be a significant amount. And sometimes they provide ancillary services. Ancillary service in the sense, for example, we are all familiar, third year and final students may know, the power generation must meet the demand and losses at every time. If there is any imbalance, the frequency in the system will change. If the imbalance is so huge, the system may collapse. So this has to be always balanced. So the demand keeps changing. So accordingly, the generation has to be adjusted. So suddenly, suppose the demand is low, high. So these sources, these batteries can give a fraction of that much load so that they can provide some ancillary services which can help us maintain frequency, everything within that limits. These are all ancillary services. Sometimes they provide. And they will also be part of peak swapping and valley filling. If you're not familiar with this term, for example, if you look at the load curve, we get in the morning, everybody uses electricity, it will be very high. In the night, everybody uses electricity, all industries are functional, so electricity consumption will be very high. So there will be two peaks in a day. And if you look at the daytime, mostly in the afternoon time and the late night time, electricity consumption is very low. So if you look at that load curve, a daily load curve, there will be two peaks and some valleys. But now, if electric vehicles start supplying power back to during difficult times, so the curve can be adjusted. So that means the peak can be shifted to the other places so that you can have a somewhat nice curve, which will help us in many ways. So that means by giving power back to the grid, they will help us achieve these two things. And the main thing is they are going to facilitate the integration of renewable energy sources. How? Suppose the renewable energy production is very high. You make all your EVs charge, store them in a battery. And when your renewable energy production is not there, you ask all EVs batteries to discharge and give power back to the grid. So the energy what you are getting from the grid is clean because that was produced by renewable energy sources that got stored in the batteries. So that means they're going to help integrate renewable energy sources. They're going to help facilitate the integration process. These are the benefits. Of course, there will be some, issues also. We have to take care of them. But in order to achieve or get all those benefits, one EV may not be sufficient. We need to have a lot of EVs. That means all users, they should agree first of all, right? If I'm not interested in participating in this thing, and it won't work. So that means everybody should be ready to be part of this one. For that, you need a large fleet, large number of EVs. Of course, in order to do all those things, the infrastructure should be proper. We should have a dedicated infrastructure for this thing. It should be able to accommodate the bidirectional power flow. That is may not be possible in the existing system. That should be possible in the smart grid. And finally, our concerns should also be taken. These are the requirements in order to achieve these benefits. I can give you some, a figure. Suppose there are 250 million cars which can be returned, which can be set in Indian number system. 25 crore cars, assume that they are all electric vehicles. Because we are going to have 30% or 40% EVs by 2030. So of course, that will be 10% of, suppose 10% of all the EVs, they agree to be part of this one. And if you look at the battery capacity, every vehicle comes with 20 kilowatt hour battery capacity on an average. If you take 10% of 250 million cars of 20 kilowatt, of each having 20 kilowatt hour, the total capacity is 500 gigawatt hour. 1 hour you'll get 500 gigawatt hour power. If you look at the energy, this much energy, it's a huge amount. So we can achieve all the benefits mentioned in this slide. If 10% of EVs, if they agree to be part of this process. Right. Now, these are the benefits. But when they are connected to the grid, there will be some problem. Then if you look at the impacts of PVs, though they offer many benefits that we saw in the previous slide, and there will be a lot of issues because the power flow is bidirectional, and then when they get charged, there will be power quality issues, and then there will be more losses, and sometimes the voltage regulation is also not within the limits. It will be very high. So these are the issues we have to take care of them because this is the main component in the smart grid. So if you want to take care of all those issues, a simple solution proposed in the literature is there should be some coordination among themselves. So it's one of the possible solutions. There will be many other solutions. It's a simple and possible solution, one of the possible solutions to take care of the issues mentioned here. Some coordination. If you coordinate, then whenever we coordinate and do some work, it will be good. The same way, if you make them coordinate among themselves, then we can minimize all the impacts mentioned in the slide. So we can take their benefits with the minimal impacts just by making them coordinate. That is the first component. If you look at the second component, which I want to discuss, is microgrid. So that time I didn't discuss the definition of microgrid. Now I will talk about the definition, so you will come to know what it is clearly. So it's a simple, a system. As you can say, it's a miniaturized version of a grid. a small grid consisting of sources, loads with clear boundaries. They are all connected together. And this small system is normally connected to the main system, main grid. And if there is any problem in the main grid, the small grid system can disconnect from the main system and work independently. If you can achieve that one, and that particular small system can be called as a microgrid. You can say, assume that there are 5-6 houses, and these 5-6 houses are connected together, and they are normally always they are connected to the main system. Suppose there is a problem in the main grid. What problem? Suppose there is a fault. There is a disruption in the electricity supply. These 5 houses should disconnect from the main system and work independently. So if you want them to work independently, there should be some generation. Then only the 5 houses can get electricity. So that means they should have sufficient amount of generation. That is why the definition says it's a localized group of sources, loads with some clear boundaries. They can work with grid connected mode or in an islanded mode. So for that, you need to have some sources in the system. So what is the advantage of going for this one? This will help us achieve the benefits mentioned in the smart grid. The benefits, purpose of smart grid is it should be able to take care of the disruption itself, that is self-healing. If there is any problem, it should be able to take care of it. And if there is any disruption, the power should be routed through different ways. But if you have a system like this, microgrid, suppose there is a problem in the main grid. This you can see in this slide. The picture has been taken from the internet, and you can see there is a switch with on-off button has been given. So in the on-off button, if the button is on, in the simple terms, we can say if the switch is on, that means the system is connected to the main system. Suppose there is a problem in the main system. This system can get disconnected and work independently. That means if it is off, it will work independently. So whatever power demanded in this local system will be given by the sources available in the system itself. So this will improve reliability, minimize losses. It will self-heal. So assume that if you have systems like this, if there are several systems like this, they normally get connected and work together. If there is any problem in the main system, they get disconnected and work independently. And if the problem in the main system is restored, they will come back again to the main system, they will work. So get connected and disconnected. So by which we can achieve a lot of benefits. So you can say now from this particular slide, smart grid is nothing but is a combination of several such microgrids. If you have several such systems and connect together, and that grid can be called a smart grid. So whatever the problems we have now, suppose what problem we have, suppose there is a fault in a line, the end consumers will not get electricity till the faulty portion is rectified. That is how we have been getting electricity. Suppose you belong to a microgrid, and the microgrid normally gets power from the main grid. There is a fault in the main line. Okay. So now what the microgrid will do is it will get disconnected from the main grid and work independently. How? They are going to have some small amount of generating units, maybe through solar rooftop or wind turbines or some fuel cells, a small amount of generation units by which the loads in the local area get supplied with the battery sources. And if the problem is rectified, the system can get connected to the main and work. Just imagine if you have a system like this. So that particular system is called a microgrid. And if you have several microgrids, and those microgrids, combinedly form a smart grid. That's it. It's a good thing in the microgrid. This concept was introduced just a decade ago. After smart grid, this concept was introduced mainly to integrate renewable energy sources. This grid will facilitate renewable energy sources because our main aim is to accommodate more and more renewables into the existing system and electric vehicles. So in order to accommodate, the traditional system is not sufficient. So that's why we need to modernize. So when you want to modernize, we have to have several benefits. So for that, this will help us achieve all those benefits and reach the vision of us. About what is our vision? We need to make this grid smart. That is possible by having several microgrids. Advantages from my definition, from your experience, you can see if you already known about this thing, these things should have been obvious now. You can see reliable supply will get. Energy efficiency. Why energy efficiency? Because we consume and generate and consume locally. No transmission losses. And minimization of overall energy consumption, because we can minimize, optimally we can use it. Environmental effect, because it's expected that all the sources in the microgrids are from renewable energy sources. It is expected. So environmental impact is very less. Congestion relief, network benefits, we'll get other benefits. Loss reduction, there is no congestion in the transmission line. Voltage can also be controlled. Otherwise, voltage in the far end of the distribution system is always very low. You know that. So that can be controlled if the system, if you have a microgrid. Right. Now, shall I go ahead or is time up? Now it's 3:57.
Sir,
is it time to wind? Or I'll time to take some questions? Is it okay?
It's your wish, sir. So if you feel so we can.
Yeah, okay, fine. Now, I think I will stop here.
Yes.
We will take some questions from the points, whatever I have discussed.
Yes, sir.
Okay. Please let me know if there are any questions from audience.
Yes. So, dear students, so if you have any query, just one by one, you can unmute yourself and you can ask question.
From the topics which we have seen
Yes,
now.
yes.
Yeah, Balaji, please coordinate with the students. Mr. Balaji?
Yes, sir.
Yeah, please coordinate with the students. If there are any questions, they can ask.
Yes, sir. Okay, sir. Sir, good evening, sir.
Yeah, good evening.
Sir, by considering VTG and J2V technologies, is there any effect for grid stability while charging EVs, particularly during peak hours?
Yes, during peak powers, if all the vehicles start charging, then the load will increase. That will affect the stability of the grid, and also it will increase losses in the system. That is why we need to have a coordinated charging. So coordinated charging in the sense, we should not let them charge all the vehicles charge during the peak hours. We should provide some incentives so that they will automatically charge during the off-peak hours. Without incentives, people will not do, because otherwise, how can we force them to do this? Because they want their batteries to be fully charged. So whenever they want, they should be able to do. But if you provide some incentives, and they may change their charging pattern. So instead of doing it during peak hours, they may do it in off-peak hours.
Okay, sir. Thank you, sir.
Okay.
Sir,
Yes.
is there any latest technology to reduce transmission and distribution losses in power grids, other transmission, HVDC and efficient transformers, sir?
Actually, I showed you that losses in particularly India is 25%, right? I showed you in the first slide. That includes, you can look at this slide, ATC, that means aggregate technical and commercial losses. So apart from technical losses, that is mainly due to I square or losses. So in order to minimize I square or losses, that's why we are going for high voltage transmission. Now we are going up to 1000 kV. Even then, there will be some resistance. Even if you use low resistive material, there will be some resistance and there will be some losses. That is there. But apart from this, there is one more term that's called commercial losses. That means here many people do not pay electricity, bills, and many people do not. Many people consume electricity illegally. So they are all accounted in this thing. So that is the reason. Suppose meter is not functional, So that means electricity bill will not be paid by, maybe because of that reason. And if energy is theft, everything is included. If you take care of all those things, if you minimize them, then the transmission loss will be only due to technical part, that is I square R. So if you want to minimize only that thing, is the material has to be that one. The material what we use, aluminum has certain amount of resistance. So if you want to minimize it, then you have to go for high voltage. That is the only thing by which that is a minimum amount you cannot do. You cannot minimize below that one. If you want to completely eliminate it, if you want to bring it to 1%, then you should not have generators far away from load centers. You should try to generate locally, consume locally. That may be possible in future systems.
Thank you, sir.
Okay.
Good evening, sir.
Good evening.
Sir, is it possible to automate a power grid to a convenient way, sir? If we can do that, how can we overcome that security issues, sir?
It is possible to automate. That should be the goal of us in the future system. It may not be possible now. If you automate it, for that you need to have sensors, and then all the equipment should have all the facilities which I talked about, bidirectional communication with secure communication. That is also important. And everywhere the sensors, they should also be able to communicate with various things. Then only you can automate. Automation, automation requires a lot of things. And then you can achieve. If there is any problem, then automatically it can communicate with other things. It can, redirect or self-heal. You can do all those things. So for that, many things are required. So that means we have to invest something. So that's why every country has started doing on these things. With the help of latest technologies, we can automate not only in generation, transmission, distribution, everywhere we can do it. Then if we do everything, finally that grid will become smart, because it is going to achieve all the benefits mentioned here. So that's what we can do it. It's possible. It's possible with the help of, technologies and sensors and investment, it's possible. Is this answer okay?
Sir, but how can we overcome the security issues, sir? Like if some other can...
Yes. That is a different topic. Even computer science researchers are working on that topic. Even electrical engineers also, researchers are working on topic. How to have secure communication, how to avoid false injections, how to, avoid cyber attacks. Of course, they are all challenges. So whenever you invent a new thing, there will be some, pros and cons. So we have to address all those things. That's a different topic. Yes, true. They are all major topics, particularly in computer science engineering and electrical engineering. That's just smart security itself is a big challenge.
Okay, sir.
Sir, could you show to our students that some path, that what kind of opportunities are available under the head of smart grids or electric vehicles, so that our students may get benefit out of it, just in a brief?
Okay, fine. Actually, you must have heard about a lot of startups. Even here also we have an incubation center which funds startups. Even I am a mentor of one startup where they have invented foldable electric vehicles, foldable thing. And one more startup, they are in the process of inventing a new motor with a lot of benefits than the conventional motors used in some EVs, like brushless, DC motors. Some EVs use induction motors, some UVs, and they are coming up with a new technology so that with minimal cost, you can achieve a lot of things. So there are many startups, particularly in EVs. And then many young graduates are there. Even here also, there are, I think, 2-3 startups. they got some funding from here, and they are working on this thing, and they have patented those concepts. One is foldable electric vehicle, people can carry and move forward, and then batteries, new battery technology, and new motors, and also battery management system. That is also a big thing. Electrical engineers are in full demand. Battery management system. So you must have seen I think not now, last year, many two-wheelers, two-wheeler EVs, two-wheeler, particular three-wheeler EV is getting blasted, exploded.
Yes.
That is because of charging. That means during charging, you will get a lot of heat. That has to be taken care of it. So the battery management system should, indicate that temperature and other things. And if there is any overcharging, it has to automatically stop. So where electrical engineers are in full demand, particularly when it comes to EVs, because there are a lot of startups, mainly on battery management system, new battery technology, and vehicles. I've seen so many startups, particularly young electrical engineering graduates, and they are involved in this one. Particularly in this topic, of course, they are all working in many startups, but as far as this topic is concerned, I have seen so many startups, students, young graduates are working on this field. So you have a lot of opportunities, particularly in EVs,
Thank you. Thank you.
Okay.
Yeah, any more questions, Balaji?
Sir, I think no, sir.
Yeah, then I request Mr. Subba Reddy to express the vote of thanks.
Okay, sir. So, first of all, I would like to extend my heartfelt gratitude to our speaker, Dr. S. Sivasubramani, for presenting us with such a wonderful webinar. Next, I sincerely thank our HOD, Ratnakar sir, faculty coordinator, Jyotilal sir, for this marvelous opportunity. I also thank our department faculty for their encouragement and each and every one of you for making our seminar on Smart Grid a resounding success. As we wrap up this seminar with new ideas, let's use what we have learned to make smart grids more popular and help create a future where we use energy in a more eco-friendly and efficient way. Thank you once again for your presence and participation. We look forward to continuing our journey toward a smarter, greener grid together. Thank you all.
Thank you. Thank you.
Thank you, sir. Thanks.
Okay.
Thank you very much.
It was a wonderful concluding note. Okay. Thank you. If there are no questions. Okay, thank you.
Thank you for giving opportunity.
Okay, fine. Thank you.
Right, sir.
So
We'll
if
be in
there are no
touch with you.
questions, yeah, tell me please.
Yeah, we'll be in touch with you, sir.
Okay, fine.
Regarding if there are any opportunity for the internship for our students.
Yes.
So we'll be in touch with you. Please help us.
Okay, fine.
Thank you, sir.
Thank you. Okay. Thank you. So can I leave now?
Yes, sir. Yes.
Okay, thank you all. Thank you. Okay.
Thank you, sir. Thank you, sir.